For students that are planning on continuing their education and transferring to university, it's highly likely that you'll have to take more than just college algebra. For some of us, we will need to take finite math. But what is finite math? I had never heard of finite before glancing at my degree plan. Jay Davidson tells us that finite math is a tool used to solve mathematical problems that exist in everyday workplace situations. A part of finite math is linear programming. Thomas Ferguson wrote that linear programming may be defined as the problem of maximizing or minimizing a linear function subject to linear constraints. These constraints are real-world items, and finding out how much of item A and how much of item B should be used to maximize profits is an example of a real-world linear equation. An easy solution to solving these sorts of problems is by using the simplex method. The simplex method was invented by George Dantzig. Dantzig was working with the U.S. Army and was trying to find an inexpensive solution to distributing supplies. He came up with the simplex method. There are several steps to be used in order to take benefit of the simplex method. Step one is you need to know how to read a basic maximization word problem. Second, you need to know how to be able to take information from the problem and find the constraints and variables and create inequalities. Third is adding slack variables to your inequalities. Slack variables are added on to an equality. Slack variables are added to an inequality to create an equality. The fourth step is to use our equalities to write our simplex table. The fifth and final step is to solve our simplex matrix by using the row-opt program on a scientific calculator. So let's take a look at a real-world problem given to us by Lyle, Greenwell, and Ritchie out of Finite Mathematics. The manufacturer of bicycles builds racing, touring, and mountain models. The bicycles are made of both aluminum and steel. The company has available 91,800 units of steel and 42,000 units of aluminum. The racing, touring, and mountain models need 17, 27, and 34 units of steel and 12, 21, and 15 units of aluminum, respectively. How many of each type of bicycle should be made in order to maximize profits? The company makes $8 per racing bike, $12 per touring bike, and $22 per mountain bike. And what is the maximum possible profit? But looking at the last two questions of this problem, we know that we need to find the maximum possible profit and how many of each bike should be produced. Something that an actual bicycle company may have to figure out. So let's move on to step 2, finding our constraints and variables and writing inequalities. By looking at the question, how many of each bike should be produced, we know that our variables are going to be bicycle models. For this example, we will let racing equal X, touring equal Y, and mountain equal Z. We also have some constraints to look at as well. Constraint 1 is the amount of steel used to create bicycles. The second constraint is the amount of aluminum used. We know that we have a total amount of 91,800 units of steel, which means that we need to use less than or equal to that amount. We also have a total of 42,000 units of aluminum, which means we need to use less than or equal to that amount as well. By looking at the last question of our problem, we also see that we have a final constraint, which is maximizing profits. Let's draw a table of our constraints. Looking at this table, we now have our inequalities. We want to maximize P, or profits, which is equal to 8x plus 12y plus 22z, subject to the inequalities 17x plus 27y plus 34z, which is less than or equal to 91,800, and 12x, 21y, 15z, which is less than or equal to 42,000. We know that the bicycle company cannot create a negative number of bikes, so x, y, and z must be greater than or equal to 0. Next, to get our equalities, we need to add a slack variable. We have two inequalities to add slack to. 17x plus 27y plus 34z plus slack variable 1 equals 91,800, and 12x plus 21y plus 15z plus slack variable 2 equals 42,000. So now we need to put this information into a matrix. For a matrix, we need to set our profits equal to 0. This is written as negative 8x minus 12y minus 22z plus p equals 0. Using our calculator, we will create a 3 by 7 matrix and enter the following information. Columns of the matrix that contain 1, 1, and the rest zeros is a basic column, and the other columns are non-basic. In order for us to solve this problem, we need to get rid of the negative numbers in the profits row. We do this by finding corner points and then pivot our matrix. In order to do that, we use the program row-offs on our scientific calculator. To find our pivot point, we first need to locate the most negative number in the profits row, and this gives us our pivot column. In this point of the problem, the most negative number is negative 22, so our pivot column is 3. Next, we need to find our pivot row. We do this by using the first 2 rows and dividing the limits by their corresponding column number. The least positive number will be our pivot point. So 91,800 divided by 34 equals 2,700, and 42,000 divided by 15 equals 2,800. So our pivot point is row 1, column 3. From here, we need to get our pivot point down to 1. Using row-offs, we will multiply row 1 by negative. Using row-offs, we will multiply row 1 by 1 divided by 34. Next, we will pivot on row 1, column 3. This changes our matrix to look like this. You can see that there are no negative numbers in our answer row or in the basic columns, so our answer is solved. All non-basic columns equal 0, and our basic columns are equal to the limit number corresponding to the row with the 1 in it. So x equals 0, y equals 0, z equals 2,700, slack variable 1 equals 0, slack variable 2 equals 1,500, and profits equals 59,400. Given these results, we see that the bicycle company will maximize profits if they make 2,700 mountain bikes and only mountain bikes. Our slack variable 2 shows us that we have 1,500 units of aluminum left over, and our profits are $59,400. This is a real-world problem that was solved by using the simplex method, and this happens every day. Any kind of business can take advantage of this method to advise them on how to maximize whatever they need maximized. This doesn't only work with profits. We have all grown up listening to math teachers telling us that one day we will need to learn that certain math problem. When it comes to finite math and the simplex method, those teachers were right. The simplex method is a valuable tool to aid in problems that come up in business and economics. Thank you.